Hello everyone. Good afternoon and welcome to today's webinar organized in collaboration with GeoWorks, Bentley and WSP. So for those of you who are new to GeoWorks is a geospatial industry center set up by the Singapore Land Authority with the main objectives of driving geospatial innovation, business growth and fostering a well-connected geospatial community. So in line with building the capabilities of our geo community, we've collaborated with Bentley, our geo partner, and WSP to share more about digital twins for smarter infrastructure. If you have any questions during the webinar, please feel free to leave them in the Q&A chat box. And without further ado, I'll be introducing the first speaker that we have today, who is Jakob, the Director of the Success Advisory of Bentley APAC. Jakob, over to you.
All right. Hello everyone. Can you hear me okay?
Yeah, we can hear you.
Fantastic. Thank you so much for inviting us and for the introduction. So let me just share my screen. If you could confirm you're okay with the screen.
Yep, we are.
Perfect. Okay, so again, warm welcome everyone. I see there are faces from across different regions. Australia, we have a bit of the mostly Singapore, of course, but whoever was able to wake up in the morning, possibly from Europe as well. So I'm going to talk today about the digital twins for smart infrastructure. I'm going to explain the context, the industry context, the need, some of the concepts, which hopefully will provide you the reasoning why we're investing a lot in such a capability. So a bit about myself. So I'm based in Singapore, relocated here about 2 years ago. And I've been involved in a number of activities here, also with some of the government agencies, and now we are providing something that we call Success Advisory. If you don't know Bentley, we provide software solutions to engineers, architects who design, build, and also operate the infrastructure, which is sustainable and smart. We have about 4,500 employees across 170 countries. For those who are in Singapore, I'm sure you are familiar with some of the examples with this architecture. Of course, Marina Bay Sands. So for as an example of a project we're involved in, we've actually been providing solutions to design the Science Museum here, the Science Museum, but also the structure for the Marina Bay Sands, also the bridge, but also the geotechnical information and simulation below ground. So giving a bit of a context, I'm sure you sort of personally feel that there is a certain trend that we are experiencing. More and more people are actually moving towards the cities. And therefore, there is a big pressure on the cities, right? Singapore, of course, has limited space, can go up and down, and there is going to be a number of up to 70% of people will actually live in cities going forward. But we also see that the cities will become digital and are becoming digital. And today I'm going to be focusing less on the cities context, but more towards the infrastructure assets. So what we see is that our future is, of course, smart, and I will be defining what it means precisely, but also our future is more and more open, and this is part of our strategy. We understand that, especially for the big infrastructure owners, where you're trying to combine disparate systems, disparate data sources together, whether these are IoT sensors, engineering data coming from designers, contractors, any other services that might come together, you need an open system to be able to actually harvest the data to the fullest, and also remove that lock-in that is quite a concern for many owners. And of course, what we mean by different sources is that we see that course, more and more assets such as building, roads, rail are generating an increasingly bigger amount of data, right? So the key problem now becomes not only structuring this data properly, so it's readable, accessible, mobile, of the right quality, but also linking this data together, bridging the gaps together. We could call it, an internet of twins. We're coming different twins coming together. So it's all about being able to leverage and fully connected contextual data, not just based on one system, but perhaps based on other systems input as well. So when we typically deliver projects, you will see that there is typically a number of repositories. It's folders or not folders, whatever is the repository where the data is typically being stored, whether you internal drive, maybe some Dropbox or whatever it is. But you can see that there is a number of, we're creating silos here because this data is not really connected. So the key idea here is actually to create a more centralized or at least connected database information that actually provides us a number of opportunities. And so we want to, of course, templatize instead of having, maybe you have 10, 20 projects, but typically 20 projects will require potentially different systems. You might have different preferences. So the key idea here is to standardize and potentially standardize the setup, standardize the core of your information, and then possibly if you have some variations, you can of course add to those, but the core of the information when you're delivering infrastructure assets should be as much standardized as possible. So and why do we need that? Because also what we're trying to do is trying to collect disparate data. And in this example, we have geotechnical data, borehole data from across the country is being pulled together in one single repository. And you can then also update this repository as you go forward and have a database which pulls data together as needed for specific projects, right? So you might have, this is just an example of a data. Another thing to consider is that it's not just about the overground. So typically when we think about infrastructure, it might be, we build a road, a rail, maybe a station, an airport, whatever it is. But actually what we must realize is that it's about connecting different also systems that are coming from the underground assets, right? So it's both underground and overground asset because, of course, especially the underground, the ground itself is being shared across the participants. So what is smart infrastructure in general? How would I define that? Well, first of all, for me, infrastructure which is smart is an infrastructure that I can query. It's the ability to find things. So here you can have an example of an inspection engineer who is able to access information anytime, anywhere, or even contextually. But it's also the ability to interact with things, with infrastructure assets. So here you have an example of the augmented reality technology. You're able to interact, visualize, comment, understand it much better. And you can think about disparate teams coming together from different regions and working on the same asset as well. But it's also potentially an infrastructure which I can talk to. So imagine being able to use potentially voice control to interact with a twin, assuming you, of course, have that twin, have that information available. So you are able to interact it much easier without even handheld devices potentially. But it's also infrastructure which I can inspect remotely. This is now, of course, possible with digital twins. In this example, we've worked with Microsoft and we're using the real-time high fidelity rendering capabilities here to allow multiple experts to inspect the same asset from different locations at the same time. And one of the benefits which was measured there is that they saved about 40% of labor cost on each inspection. Now, it's also the ability to recognize things without human intervention. And as the infrastructure ages, and we know that 99% of infrastructure is the existing infrastructure, is brownfield. So how can we ensure that we can possibly find cracks, maybe recognize the cracks on the bridge? Maybe we can use drones and photogrammetry scanning to do it automatically. But if we go back to the CapEx project delivery, of course, what we want to do is we want to be able to oversee as the project actually is going through this journey. And as the owner, we might want to manage your capital project expenditure, more cash flow management, look at as the things get erected. Do I need to release some payment to certain contractors or the main contractor? So of course, it's becoming more and more critical. And coming back to this ability to interacting with things, so here another example of augmented reality technology, where you can visualize, comment, understand the infrastructure much better, whether it's interiors or exteriors, but it all comes down to be able to actually having that information asset available in the first place. Finally, there is this other capability here, which is all about monitoring of infrastructure assets. This is something that we co-developed with Siemens. Here you have a plant infrastructures. Of course, we built a 3D model here with photogrammetry, with photos. So you can create this geospatial information, mesh information, and then attach data to it. And this data can be, of course, interactive, can come from sensors and so forth. Now, going back towards the operation side as well, and of course, energy management and especially green energy is something that is very dear to our heart. It's like, how can you now predict potentially the amount of energy that a particular wind farm is going to generate to you, right? So we can apply here algorithms such as AI or generally just collecting different data sources together to understand, predict, whether we will have some downturn or whether we need to maybe supplement this clean energy with some other energy sources to fuel our city. And another example that we've also been working on with Microsoft here is to potentially, as a scenario here, imagine you want to protect a particular infrastructure because you want to be able to intervene when appropriate. So maybe you can see there is a particular sensor which looks into the increase in CO2 emissions or other gases, and maybe you want to see what's actually happening. So you of course install live stream cameras from that particular tunnel, and then you might send help with the intervention going forward. So for those who are not familiar with a digital twin, generally I will mention this briefly. It's about having this representation, which is virtual representation of a physical asset, but this could be also process or system. And the idea here is to also keep this information current, right? So we need to continuously synchronize, survey, and the decision is up to us whether this is every second, every millisecond, or every week when we are actually surveying and updating the infrastructure. And we for sure we want to make sure that these particular digital asset generates insights to make informed decisions. And in fact, if we come back to why digital twins are actually so valuable, first of all is being able to make informed decisions, answer those critical questions, right? So what are the questions do we have about a particular infrastructure assets? So, who is responsible for it? Where is this asset? When certain things need to happen, right? So all of these are questions. So once those questions are answered, we know how to carry critical activities. So what I mean by that? Well, a critical activity could be something like an inspection, could be something like possibly a work order, whether it's during construction or whether it's during operations. So there will be maintenance activities or construction activities or design activities. So we want to understand, of course, you want to carry those activities, but we want to carry the right activities at the right time by the right person. So let me switch gears a little bit and let me show you what's happening in other industries. For instance, we learn from other applications in here. This is an example of Formula One, where the teams were actually able to make up to 1,000 changes to the vehicle between races, right? So how did they do that? Well, they were simulating the race to prevent accidents, possibly optimize car performance or redesign the parts, maybe optimize fuel consumption, and generally avoid failure, right? So what we're talking here is actually the outcomes that the team was trying to achieve. This is very much applicable to the built environment, where you again collect different data sources. You want to analyze, vibration patterns, aerodynamics, or whatever you name it. But it's about making these improvements between races in this case. So it's, of course, there is this focus on outcomes. Another aspect to consider, and this is coming from the aircraft industry, but now we see something similar being applied to the elevators in our industry, is where you're not only selling the engine, but you're actually leasing the engine to the owner of the aircraft, in this case, Rolls-Royce to Boeing. And so you can see that there is a different business model here, because it's becoming a subscription business model where you're subscribing to the engine service, to the power by the hour, in fact, was the model. And so you can see that we're redefining the way we're providing value, right? And of course, there are other outcomes in the built environment which we want to see, which are maybe around reducing the traffic, reducing accident rate, or on an optimized energy performance. So the key question for me is, or the key concept for me is not really to provide the answer, right? So in this scenario, John is saying, I have the answer. So when you are actually providing a digital asset, whether it's a BIM model, digital twin, or information model, you're basically providing the answer, right? So you're giving them the information, which is the answer. So for me, the more important thing is actually the question. So do you have the right question? What do I mean by that? When we are designing a digital strategy, typically we want to identify the various questions that we might have. For instance, in the operations space, is who has the maintenance contract, what is the current energy consumption, and so forth, right? And of course, you can have a number of other questions. Maybe in the construction space is all about maybe if you are building and you want a crane, so what other contractors were providing this similar crane in this region? And this is, there is a lot of ways of actually looking into the twin for the infrastructure. This is an example for the rail assets, where we are combining different type of representation, whether it's 3D representation, whether it's tabular view, or schematic. So it's all about, it doesn't mean that it needs to be necessarily a 3D. It could be a 3D. This is the 3D will give you contextual information, but of course, we are also about all these other type of information assets. And one of the first, I'm bringing this up because this is one of the first digital twins or digital railways in the world. Crossrail, and so how did they do that? So what was their need and what did they bring together? Well, they pulled together information about disparate systems, whether these are building management systems, CCTV security systems, escalators, to be able maybe look into a particular asset, how much energy does it consume, is it faulty, how often does it break, how many, and then maybe you can monitor how many people throughput a day do you have and so forth. So it's all about understanding, first of all, what outcomes do you need, what questions do you have around that, and then providing the answer around particular questions. So it's about connecting the physical twin and digital twin, having this questioning strategy, and then building the interface, right? Whether this is a voice control or other type of interface, is all about collecting data from the physical twin and then providing insights and making decisions, and then planning for the interventions, whether these are construction interventions or whether these are operation and maintenance interventions, right? So of course, going to the outcome. And what we want to do is we want to, of course, link the physical assets. So here you have the rail assets and then the digital assets. So what are these digital assets? Well, I was mentioning already 3D models, some PDFs, documents are still digital assets. You have databases, spreadsheets, you have some maybe data coming from vibration data coming from the rail asset. And to connect it though with the physical twin, we use something which you call the digital ID or asset tagging. And there is the whole world of asset tagging strategies that you can apply. But of course, we want to label the particular assets and have, label not only the physical assets in terms of the actual, where there's a pole, but then also all the documentation that's physically printed. You might also connect this information together, because there will be still occasions where you want to print information, but of course that's not the direction we are going in. So now the key problem that we see is that, of course, as I mentioned before, is that we have 99% of assets are existing, right? So how do we create this asset registry, so this repository of digital assets? So what we have been working in Bentley is using artificial intelligence to recognize the assets. So we bring together the technology of photogrammetry, where you can see first of all, we did a number of camera photographies of this particular pump room. And we then combine them on the cloud. The algorithms would create these 3D models. And then we can apply machine learning to actually recognize these assets, and so the algorithm would then classify those assets, whether this is a thermometer, whether this is a pump, and so forth. And these are some of the other questions that once you do have an asset strategy, once you do have, you have an understanding of what it is, you have the questions that you want to answer, then you start to build those answers, which is the information assets. But before I conclude, let's just highlight the outcomes we are after. So we already talked about the fact that one of the outcomes is on decision making to potentially improve energy performance. We want to bring these analytics and insight capabilities, and then at the very bottom you can see we have this information that is being produced, whether these are designers, engineers, architects, or maybe this is data coming from sensors, and we want to build this digital twin, which is one of the type of the digital assets. So you can see that there is a gap here. So the gap is information management. We really need to build this capability, which provides us the trustworthy data overall. So to conclude, what does it mean to have an outcome-oriented strategy? So we define the outcome. Let's say the outcome could be productivity gains, could be energy savings, quality, whatever is the business outcomes that you might have. We would then specify which capabilities do we need to make this outcome available. And then we potentially would look into how mature the organization is on the ladder to achieve this particular capability. And then we would look into, okay, the green ones are the ones that we need to build. And then we would build something which we called a success plan, which is a series of interventions, which are maybe configuration services, maybe it's training, maybe it's change management programs, to be able to ultimately realize the benefits. So, this is, let me just maybe skip this slide here. So some final thoughts, okay, before I give voice to Keith. So first of all, general recommendation is really to start building this data foundation now, right? So no analytics capability can be built if you don't have that understanding of what data do you need, which outcomes are you trying to achieve. So build the data foundation, ensuring that your data is the right format, is accessible. Ideally, you're bringing this data together in an open format. Another thing is to ensure that you want to align your digital strategy, whatever it is, whether you have a strategy to be able to maybe put together a connected data environment, but then how does it align with your business strategy, which is maybe win more work or provide better performance of my asset. And finally, do not forget, technology only plays only a part. It's all about behavioral change, about people actually adopting these new capabilities in business as usual. Okay, so I will stop here, and I'm happy to answer any queries you might have later on. So Keith, over to you.
Thank you, Jakob. So, okay. So can everybody see me?
Yes.
Yeah, that's great. Let me start let me share my screen first. Oh, wait. Get this right. And where is? Okay, so I'll share my screen here. Hopefully you can see my screen now.
Not yet.
Not yet.
Yeah, so Jakob, that's a hard presentation to follow. At least you covered most of the things I'm covering, so it's good. I can skip through a lot. You skip from my time, so I can skip.
Oh, sorry for that.
That's perfect. That's perfect, Jakob. A really fantastic presentation. I think some things might answer some questions that some people had. I see there's people here from far afield in Australia and other people in Malaysia, and of course people in Singapore and other places. So good morning, good afternoon, good evening, everybody. Happy that you can join us. Let me just look for I can't see you anyway. Hopefully you can see me.
Yes. Can you share your screen?
Sorry.
Can you share your screen?
I'm not sharing my screen.
No.
Really? Okay, strange. I thought my screen was sharing, but here it's showing it's sharing. Oh, okay. Now it is.
Yeah.
Now it is. Yep. Okay, great. Sorry about that. Yeah, so welcome everyone. Thanks, and thanks to SLA and GeoWorks for inviting me to speak on this. And also I'd like to say thanks to all the contributors to this presentation. A lot of it is, of course, Bentley, because Bentley has a lot of infrastructure digital twins up their sleeve, as Jakob just showed. And of course, stuff from my colleagues. We're doing a lot of things around the world on digital twins in WSP. So a little bit about myself. I've been in the industry, in the construction industry, for more than 35 years. Also with a few years prior to that in oil and gas industry. I have always believed in using technology all my life, ever since I started out in oil and gas, using the predecessor of GPS to digital twins today. You know, we've come a long way in those years. Some of the first computers we used to these huge computers to what we've got now in our watches and everything. So a little bit, just a few contents, just introduction I've given. I'll give you a little bit of background. We're doing a lot in smart cities and being future ready. And I think digital twins will always be a help in this. And it will be a way of the way we're moving forward and a way of life in the future. So Jakob, you did say, what is a digital twin? So as you said, a digital twin is the representation of the real asset. The digital twin is only as good as how it's developed, what thought process has gone to it, and what information you get out of it. It requires a bi-directional connection between the real and the virtual asset. This virtual asset, it can be either in 3D or in 2D. And as recently presented on a presentation on the smart and digital twins in UK, a digital twin is not really a lot of monitors on the wall of your traffic management system. That's not really a digital twin. A digital twin is a representation of what you have outside, what is a real asset. So, as I said, smart cities. WSP are working on a lot of smart cities around the world. So are all other consultants. And a lot of these smart cities require digital twins, whether it's for the smart buildings, smart infrastructure, smart utilities, intelligent transport systems. All these have connected data between the real and the physical and the virtual asset. We have, I can't remember, a number of projects ongoing in the Middle East with smart cities. We have projects ongoing in the US, in UK, in Europe. We have a lot of smart buildings here in Asia and smart infrastructure in Asia. But everybody seems to be moving in this direction, and it will be, I guess, the bread and butter for many in the next 10 to 20 years. Why do we need to look at the future? Are you ready for the future? I guess many of you can recognize Singapore there. This is just a heat map of Singapore showing the difference in temperature, but it also shows, will show in the future how the temperature is rising, how using digitally mapping this temperature rise and the effects it has on our services, whether it be the rail networks, the utility lines. This increase in temperature will require increase in maintenance. And having these utilities and these services, these infrastructure services digitally linked will enable us to have a better control on what is happening. Again, with this is again Singapore, but many of you saw, or I guess everybody heard the news in China with the flooding in the subway system. Once again, if there was a digital twin of the subway system, could this have helped? could have saved the people. It probably could have, if the sensors were there, if the system was set up correctly. They would have been able to get enough early warning to get people out in time. But it's all a matter of having the right information in the right place at the right time to predict these effects. Water usage. A lot of countries around the world are struggling with their water supply. The digital twins of water utility services are becoming more commonplace. This allows for sensors to be put in place to be able to track the usage, track any leaks, and be able to react before something happens. Again, also the other environmental factor, of course, would be the rising sea level. These are all things of the future where being able to digitally map these issues around the world, these environmental issues, will help us tremendously. But going on to digital twins, as we're talking about in this seminar, what are digital twins? What are the daily activities? Many organizations think a digital twin is your 3D BIM model. That's not really your digital twin. Sure, that's the start of the digital twin. It's used on the project planning, the conceptual design, assessing the design throughout all the project life cycles. This may not be in order as I put there, but a digital twin during the construction can be used for stakeholder engagement or prior to construction. It can be used for doing alternatives. It can be used for cost estimating, for construction proofing, maintainability and constructability proofing. So there's a lot of uses for the initial digital twin, but many owner operators forget the last three, the maintenance and asset management, optimizing operations through data analysis, and of course, rehab and future replacement. But I would say many owner operators are starting to wake up to this. Not sometimes it's because, well, I would say it's often because the manpower is becoming shortage, especially here. It's getting more and more difficult to get people to maintain your products. So being able to do it digitally and to be able to track your assets digitally is much better. There are multiple digital twin providers working out there, many software providers. This is from one of them. As I said before, we work with many owner operators, or WSP works with many owner operators around the world. So do other consultants. We also work with many software vendors. We have a lot of very big projects ongoing with Bentley in the US, here, in Australia, in Europe, in the Middle East. And we do the same with the other vendors. And there's vendors like Bentley, Autodesk, Ecodomus, Siemens, Schneider, Smart Spaces, Maximo, etc. These are all people that we work with globally, and they're all part of this new digital twin era. Again, I came through the digital twin life cycles, the conceptual planning, through to the design, through to the analysis of the models, and construction. And often in construction, the digital twin or the 3D BIM model is used just to produce the sheets, but it's often not used in stakeholder engagement. It's often not used in material takeoffs and quantities, in 4D sequencing, visualizing through AR and VR how something should be erected or assembled, or using it for DFMA, using it for health and safety, using it for logistics. I know of projects that have saved millions using this for logistics by optimizing their crane usage. But this is becoming, I think it's becoming more and more a commonplace here, but still something that needs to encourage. But hopefully going forward, they will realize the use of digital twins in asset management, and how you can optimize your buildings, your infrastructure, your services, your road usage, your rail usage, your airports, wayfinding, all through your digital twin and your sensors. As Jakub also explained, the digital twin supports decision-making on your project, on your assets, how you maintain it, how you run it, how often, what needs to be changed when. In the past, or even up to now, most people rely on corrective maintenance. So when when your asset breaks down, or you go out and repair it, this is often comes out in downtime. You lose your business, you lose income. Then there are others who use a preventive maintenance, who know that the asset has a certain life cycle, or that bolt, or that valve, or that rail, or that sleeper has a certain lifetime, and after so many hours it has to be changed. But actually that item may still have a lot more hours in it. It may not be worn. So this is where your digital twin, using predictive maintenance with IoT and machine learning, learning about how long that section of rail might last, that sleeper might last, learning that you don't need to change it every 1,000 hours. It can be 2,000 hours before you need to change it. That approach will save operators a lot of money in the future. But like Jakub said, it is something that has to be thought through. You can't go into it and jump into it without any thought process on what you're going to do. The same as years ago, or a few years ago, when people were implementing BIM, they just jumped into BIM thinking that, oh, no plan at all. Why, it's just 2D to 3D. That wasn't the case. Many of those companies are suffering. Bentley has its iTwins. We work with them on various projects in the US and in Australia on the iTwin model of their digital twin, and connecting these up with the assets. This has become a very useful tool in infrastructure. The intelligence and the information that you get from this iTwin, and the ability to have a huge amount of data in the cloud and not on somebody's computer, which with the restrictions of storage space, has helped tremendously on some of very, very large projects, also over very long lifespans. We're also working with multiple rail providers in the US. Actually, I would say, I think 5 or 6 major providers in the US with Bentley, and also with other consultants developing their digital twins of all their assets. This is just a connection of the iModel Hub with the digital twin and the different packets with the information coming between the different softwares and assets. Again, one of the things we said is that Jakub said is that there's multiple different sources of information coming in to this digital twin. It's not just one source. And there's multiple bits of information coming from different places, and it all has to come together out of its individual silos. And going forward, you will see that I think one of the silos during construction would be, of course, the design coordination, and that information has to flow between the different design parties, has to flow between maybe the suppliers or the owner operator, and through the digital twin, they're able to see that. Going back to the silos, some of you may have seen this presentation from Bentley previously. I think it was about a year ago. The consequences of the silos. Often you have, especially on rail products or projects, or even on building projects, you have multiple different people working, stakeholders working on repairing. One person may be repairing the tracks, another person repairing the signals, another person repairing the sleepers, or another person putting down bedding, something else. You know, you've got so many people, but they don't talk to each other. They don't look at the cause and effect, why something failed. But bringing this information all together and analyzing the information, bringing it out of its silos. So you have these silos all coming together. And once all that information comes together, you can analyze it, find out what is the cause and effect of any failure, or of most failures, and then plan for it in the future and look and see how to improve on those failures. Sorry, I'm losing my voice here. Excuse. So I'm just going on some of the linear track digital twins. There are so many things on the digital twins. When you've got sensors there, you've got sensors on the rail trying to picking up the information, sensors on the carriages as they go past, picking up the sound. You've got sonic sensors picking up the sound of the tracks. You've got scanners going across, and all these are much easier than using a human walking along the track as they used to do in the old days, or on his little buggy going along the track, trying to see if there's any cracks or any deformation. By doing this all remotely and collecting all this data real time, that's really saving a lot of operators a lot of money. The thing is, when the data comes in, as you can see in the middle of there, there's a lot of noise in this data. So this noise has to be ironed out. And this is looking at the tracks and the deformation of the tracks, and what is the track's life still available. With a reading every 200 meters, you're able to assess the tracks. You'd see here, of course, the heat, the red area is showing that there's issues in your tracks, and the green area is showing this. The tracks have still got good lifespan. The orange is where you should start thinking about when you're going to replace those tracks. So these are all, this is, of course, again, Bentley working together with a number of other people and a number of rail operators in the US. Again, looking at the tracks, being able to do the right work, the right time, the right place, and knowing when you're going to be able to maintain something and planning your maintenance rather than letting it fail and then you do the maintenance, or fail and an accident happens. This gives you a happier customers and a better return of income. Then, of course, what I spoke about earlier on was, I mean, this is not only in rail, road, digital twins, but also in utilities such as water supply. Being able to use software and sensors on your water supply to actually see how your water usage is. Have a look and see if there's any leaks coming up. Being able to shut off the system immediately. Being able to visualize what is happening where on your digital twin. It's all something that helps you tremendously in maintaining your assets and maintaining the life cycle of your assets. All this information coming into your digital twin, your network monitoring, your pumps, your tank performance, alerts from any breakages or sensors where there's a differential flow. You might have one flow going on one side of the sensor and then the flow is dropped on the other side, so it means there's a leak there. And being able to respond to it before the leak gets too big. Recently, I asked the owner of my property or the management of my property, has there been a change in our water bill for the property? The person said no. But when I called the utility company to come and have a look, I said, there's a leak in your main line here on the property. So it's strange that the actual owner could not see the leak in his own property, but the utility company came and actually saw there was a leak, and so it was able to get fixed. But 4 months, there's a lot of water that got lost, and it took 4 months to convince the owner that water is precious. So as I also said, we work also on a lot of intelligent transport systems. A lot of these ITS systems are still not as digital twins, but as you know, with the Digital Britain, these will all be digital twins in the next 1 or 2 years, probably within the next year. They're asking to digitize all their roadway networks to use these ITS systems. This was here, this is in China, where we do a lot of ITS systems here in Asia as well. So these are also the future of the digital twins, including, of course, the rail networks. This is in Taiwan. And the highways, this is in Hong Kong. We do a lot of stuff with the Hong Kong government, with our highways, with our road monitoring. But these are all the future of digital twins. Then just a couple of minutes, I will close out just to give you, as Jakob said, digital twins and data. I mean, there's a lot of data going back. You need to know what data you want to capture and where you want to put the sensors. What is the best thing? It's better always start small and work your way up. Don't try to do everything at once. It will fail, and always have a plan in place. And this amount of, you've got your asset tags on your assets, you've got your asset tags on your sensors, and all that is talking to your digital twin, and they should be talking to each other at all times. And of course, there's a lot of IoT and technology behind the digital twin, bringing all that data together, being able to analyze it, give the right information out, put the right information back in to tell it to do something if you're telling it remotely to do something. All that information has to be built up and made sense of. And as I said, it's a big data. For some of the rail services, they actually have transmit the data of their rolling stock to a receiver station every time the rolling stock goes by. And one day's data may be around I think it's I'm not sure, 2 gigabyte, 2 terabyte, but there's a lot of data. And I remember, I think it's 2 gigabyte of data a day, which will be transmitted to their control center every day on their rolling stock. And that data may not only be about the train, but will also be data about the tracks. And we all know with the attacks today, I mean, the cybersecurity is a big thing. And this is something that you have to look at. It's one of the biggest risks in digital twins, but it's something that is we're getting better at, and the attackers are getting better at. So we're getting better at security. The attackers are getting better at attacking. So it's a continuous step. You know, we're fighting each other, and I guess that fight will be there for many years to come. We just have to live with it, like everything else, as well as the massive data, the IoT behind it, and the interoperability between the different systems. Many governments with the smart cities, and of course, many governments are looking to be carbon neutral, and this is the one of the steps towards being carbon neutral. So sorry, I went over a little bit. Jaak went over, I went over. So there's only 3 minutes now. Anybody got some questions? Thanks, everybody. Hope you're all still awake.
Thank you, Jakob. Thank you, Keith. So I think we have 2 questions right now in the chat box. So the first question is from Alvin. Alvin is asking, what is the adoption of digital twin in Singapore? For example, the percentage of buildings or infrastructure that has some sort of digital twin. And if there is adoption, what is the maturity level of this adoption?
Jakob, you want to answer that? Because my answer would still be quite low adoption. I know there's been a lot of planning, especially in vertical. Been a lot of inquiries on it from different owners, but they've often, many of them have opted out of it, but there are companies, I believe, doing it. Many have opted out of it because they said the costs are too high. Yes, the initial costs, like everything, the initial costs are quite high, but the ROI is good over the long term. But my answer would be Singapore adoption is still quite low. Jakob?
Yeah, I would absolutely. I think, you know, I can confirm, but we are still. I think if you look at the cross section across the industry in Singapore, I think organizations are still trying to build up their information management foundation to enable to expand later on these digital twin and analytics capability. But I can mention one example, for instance, SLA, who has built a photogrammetry twin of Singapore, but that's quite recently. There is another project we're working with PUB, for instance, again around the water leakage. And by the way, Keith, I had a similar problem with my water suppliers. We had about 4 months of water leakage, if not more, but it was undiscovered, right? So, and it's a huge problem for, if you think about the city scale, a water network and distribution, you can lose a lot of water there. So I think PUB, we're doing some research projects. There are some demonstrators there. I know HDB is also applying some digital twins on their elevators. But I think it's nascent, right? I think in Singapore is fairly nascent.
Yeah, I agree. I think it's very, they're doing something, but not much. But I believe it will come as a flood quite quickly.
Mm-hmm. Especially because now you can see, you know, both the LTAs and BCAs thinking about the platforms, thinking about how to harvest data, put it together, validate it, so you ensure that this data is becoming available, it's of a quality, has enough information. So the next natural step is build services around that data, build value around that data.
Of course,
and I think, as you say, it's going to come as a flood.
Yeah, I mean, with BCA's IDD, they started at in 2018, but we've got to one stage. Now it's just the last stage. We're not there yet.
Thank you, Keith. Thank you, Jakob. So I think that kind of links to the next question that Fan was asking, whether there's any case studies of use of digital twin in Singapore. So I think you mentioned like PUB, BCA, these are very good case studies. So thank you so much, Keith and Jakob, for all your insights and your sharing. We really learned a lot from all the case studies that you have mentioned. For all the attendees today, thank you for attending the webinar. We'll be sending the recording to everyone after the webinar. So do look out for that. And with that, I'd like to wish everyone a good week ahead, and we hope that you can join us for other webinars. Thank you and see you again.
Thank you.
Thank
everyone.
you. Stay safe.
Thanks.
Stay safe.
Stay safe, everyone.